Hello again. It's the Linum Labs boys back with another Solidity Fridays. Today we're doing Squeeth. This has been quite the hype thing on crypto Twitter this week.
Squeeth.
Squeeth. Yes. Uh, it's a very fun word to say. Um, yeah, let's get into it. Will, do you want to tell us a little bit about the background and how this started?
So first of all, I do seem to be having some audio issues. So if I turn it until the robot, Dave White, who seems to basically be a serial protocol creator over at Paradigm, tweeted around when Squeeth went live that was a idea that got floated on some kind of a retreat. Because of course, what crypto people do when they're on a retreat is come up with things that sound like power perpetuals, or if you're Arthur Brightman on a honeymoon, that's a true story also, but I guess not for right now. And they came up with an idea of having a perp that's long, like you can go long on ETH. You can do so quadratically, as then instead of, or I mean, Ben, you'll probably be better at explaining this, but I guess the TLDR version is usually when you take a look at leverage, so you're going, say, 2x or 4x, times you have 2x, you'll get 8 times as much as if you're 4x, if you're a BitMEX maniac, and 100x, so you'll get 200. Power perpetuals look at making that quadratic as in a polynomial. There we go. So that if you're squared and it goes up 3x, you'll get 2 to the third, 3 to the second, which would be 9. And then also you don't get liquidated. But I think I'm probably rambling a bit, so then I'll probably hand over actually explaining it to you.
Sweet. Okay. I mean, I'm just as in the dark as you are, but I'll give it a shot. So yeah, so it started by a combination of Dave White from Paradigm, as Will said, sort of collaborating with Opyn, which is an on-chain DeFi options protocol, and I guess they came up with this idea to do leverage, but not in a sort of linear multiplication way, but more in an exponential relationship. So, I mean, I wonder if we can actually just show you. Why not? This is more of a casual Solidity Friday than usual. We don't have the intense stress of a guest today. So let's just look at a y equals x squared graph just to get an idea of that exponential relationship. I'm sure if you're watching this for the Solidity code, you probably have a good idea of how exponential relationships work. But just to recap, so this is sort of the relationship as you as ETH goes up. This would be ETH on the x-axis, the price of ETH. Your position would go up even faster than that, starting from 1, let's say. So you make sort of an exponential profit. And then also on the downside, you get a bit of a benefit where when ETH decreases in price, your position actually decreases slower than it would be if you were just to be long ETH or leverage long ETH. Yeah, so that's sort of the asymmetry here, which people are quite excited about. But to achieve that asymmetry where your downside is sort of a decreasing, tapering off thing, and then the upside is an increasing, accelerating relationship. To achieve that, they have to integrate sort of funding payments into the Squeeth instrument. So you can think of that as a continuous stream of rent payments to hold the instrument. And I think Mudit Gupta was saying that right now that's really high. I think it was like annualized at 91% or something. And that's so that chips away at your position. If we look at the Squeeth chart here.
Incidentally, I don't know if you saw that there's already a DAO forming.
A DAO around what?
Funding Squeeth. Squeeth.
Oh, so the DAO just sort of raises money and then I guess like basically LPs Squeeth, which is essentially short the Squeeth instrument, I think. And then it harvests the funding, right? Is that
it's something like that. I haven't figured it out yet. She-Generates was tweeting about it. Or actually, She-Generates was tweeting about the idea, and someone responded with like a DAO that's already planning on launching in 10 days.
Awesome. I mean, that's an interesting idea. I floated in our internal trading channel at work the idea of going long ETH, so you have the exposure to ETH, but short Squeeth to collect the funding on the Squeeth instrument. So that way you collect that that stream of geez, right now the funding is. Oh, sorry, no, that's not the funding. That was just a spot sort of reading. That way you'd still be able to, I guess, be long ETH, and as long as ETH doesn't increase in price too much, you would be in profit.
Mm-hmm.
And you can see here on this graph that ETH really has to be pumping for Squeeth to outperform. So like here, the green graph is Squeeth. Here is where Squeeth did really well because ETH was pumping. But then in these sort of sideways periods, you can see, or down, you can see just straight spot ETH, the blue graph actually does better. And that's dependent on how much it has to pump for Squeeth to outperform is dependent on the funding rate. So
Cool.
So yeah. Will, do you think that's enough of a financial overview before we dive into the code, or is there other things you'd like to?
Yeah, I'd be happy to jump right in, but I'm much more of a financial pleb. So yeah, you mentioned the internal trading channel. I'm like, do we actually tell them that it's 98% memes?
This is Wall Street Bets memes. Yeah.
All right, let's do it.
Let's get it. So here the Monorepo is from Opyn. What is a Squeeth? So it's going over what we just said. Power perpetual. Right, I think we can get in. So I've unpacked a few things here. Let's look at the structure of the repo first, I guess. View code. Oh.
Packages.
Was it there? I guess it was. Sorry.
Yeah, packages right there.
Yeah. So they include a front end here as well, and then I guess some services in there. Nice subgraph.
Like API or something.
Yeah. But we're interested in the smart contracts, so let's go there. Contracts. All right.
There is a bit of a README on the contracts, incidentally. One up from there. Right there, I think. There. Yeah. One of the sometimes I like sniping these like little interesting things. If you scroll down a little bit more, I think it talks about deploying the contracts, and they actually make you have a mnemonic in order to deploy, which is like a little bit funky.
That's interesting.
Yeah, right there. Right on deploy.
Sorry.
To start.
Mine's gonna be out of sync with yours.
Oh, I gotcha.
Right.
I'm looking at the wrong thing. Wait a second. Did I see this somewhere else? My gosh. Give me a second. It's really silly because I'm not finding it. But I thought before I saw something here where you needed to have a mnemonic.txt in order to deploy, and I'm debating if I just like completely lost my mind. Oh, in running this project, it talks about how to set up your environment, and it mentions the mnemonic seed phrase there. It's pretty close to the top in the hard hat.
Oh, yeah.
Yeah, right there.
There we go. Nice. That's weird. So they don't want a private key in your ENV. They want mnemonic.
Specifically a mnemonic.txt. Now, I'm sure they have reasons for this. One of the reasons why this is like something to be interested in hearing the justification for is your git ignore will not, I don't think will know to automatically ignore this unless maybe they put in a git ignore already that is ignoring. This is the chance you to accidentally push it into GitHub or something like that, where there are generalized bots that will be looking for something like it. And even if it's an old commit, it can get compromised. So, I mean, do you mind seeing if they have a git ignore somewhere for this? I can also check on my end. Like, I'm guessing they probably do something like that. Probably in the root.
Yeah, probably in the root.
Ignore.
Yep, git ignore. So yeah, they've got that hardhat.txt.
Oh, yeah. Yeah. Oh, now I see it. Yeah, right there at the top. All right. Interesting. So I guess they do have it auto ignored, but like still, I don't know. I guess doing something non-standard like that just irks me a little bit. But mnemonics also, like, what do you do if you have a ID that's like your deployer address? I run into this when I'm on test nets. I usually have one set deployer key. Like, how do I, like, I'd have to find a way to extract the mnemonic from that. Extracting the private key with ethers. But, like, still, like, I'd have this whole kind of weird process just to get there, even.
Yeah.
Yeah.
It's pretty weird from my perspective as well. I'm used to just plugging in a private key in the ENV.
Private key. Yeah. All right, cool. So you're looking at the libraries first, I see.
Yeah, let's sorry, I opened a few contracts here in these tabs. I'm really not sure where to start. I guess we start with core.
Yeah, that sounds good.
All right, so here in core, we have a controller, we have an Oracle, we have a GPL3 license as well. We have a short power perp, and then we have a W power perp, which I assume is wrapped. I'm not sure why
that'd be my guess
is in here. Maybe that is the contract needed to fund the thing to take the opposite side, but I guess let's check it out. So here, do you want to start with the W power perp or
sounds
controller?
Good. Either way.
Okay, let's do W power perp. Let's see what we got here. Oh, geez. Solidity 7.6. Interesting. I guess it was from when Dave White tweeted that was August last year. I think we were on 0.8 by then. Interesting.
Yeah, 0.8 then.
Okay. So let's get through it. They've got that that module import system that we've noticed before. Where did we see that before?
Soulmate does use it also. Like a lot of the Rari code does use it. I don't remember where else, but I do remember Rari for sure.
Yeah. Interesting. Okay, so they've got their interface. We might want that open if they define structs in there. But we'll see.
Oh, good point. For events, yeah.
Let me go back to that actually. So Monorepo. Gosh, pretty hard to do things when it's so zoomed in like this. Contract interfaces. Okay. We are on the wrapped perf, power perf. Okay, no structs, just a mint and a burn, huh? Interesting.
Yeah.
Okay, so here we are in the contract. I guess, yeah. So we're importing ERC20 from OpenZeppelin and initializable. There we go. So it's a pretty standard ERC20, and I assume there's going to be some other stuff baked in here.
Mm.
They've got the controller and an immutable deployer. That's interesting.
Yeah, I agree. And the deployer, deployer sender is expected, modifier only controller. So the controller, I guess, is, as its name somewhat suggests, going to be the one making the privileged calls, probably.
Yeah. That was that other contract that we saw.
Right. The other part of core.
Okay, so this does look quite chunky. Very nice. So,
yeah, and I'd say do the perp first and then get to it, maybe.
Yeah, okay. But I'm still like finding this quite interesting that they save the deployer. Maybe there isn't. No, there's not even an only deployer modifier. Very interesting.
Right, we'll need to see the I do see it getting used in init right there. Function init controller
okay.
external initializer require message.sender as deployer. As in, only the one who deploys the contract is allowed to initialize it. The controller can't be set to the 0 address, and so it's interesting. This makes me think that there might be some kind of proxy setup. That's usually where I see initializers. The other reason would be if you have a constructor that's just so big that you're running into the constructor, so you want to split it into a second function that can be called later. Like that modifier initializer, if I am not mistaken, OpenZeppelin puts in their upgradable contracts so that you won't have a constructor there, which just makes it easier for the way they set things up for proxies.
Is that out of necessity in a proxy? If I remember correctly, you can't run logic in the deployment in the constructor on a proxy. I'm not sure if
I believe that is the case, but I'm not deep enough to tell you if there's a way to bypass that. Like, unfortunately, I'm a bit of a pleb when it comes to proxies. Like, I know how to use OpenZeppelin's contract, but I haven't really dug into like what's happening under the hood when I use them.
Yeah. But if that's the case, then this would sort of imply that it's not a plot.
That it's not a proxy. Yeah. Correct. Yeah. Yeah.
Okay, cool. All right, well, let's carry on. So here we're just at mint, pretty standard ERC20 mint, only the controller can call it.
Same with the bird.
Yep, okay, well, that was
so yeah, that means there's really nothing going on over here other than the fact that it's initializable. Yeah, agreed. And if that's the case, maybe we should take a quick look at short, because I'm assuming short is going to be the same thing.
Yeah, here's short. It's an NFT. Interesting.
Oh, yeah. Okay. Yes, we falsified that hypothesis.
Yeah. Wow. Okay, very interesting. And here we go. It's an NFT representing ownership of a vault, a short position. So yeah, this is basically, I believe, where you're supplying ETH in the case of Squeeth, or if it was another asset with some power perpetual relationship, it would be that asset, and you're supplying that asset. So you're essentially short the Squeeth instrument. Yeah.
Squeeth.
And that's that's why they call it a vault, I guess, because you're supplying ETH into this vault and sort of underwriting the Squeeth. The Squeeth.
Mm-hmm.
Okay.
So next ID, I guess, is kind of their counter. They also need to know where the controller. And again, we have the immutable deployer over here. So I'm assuming it's going to be initializable also. Yeah, it says it's initializable. Yeah. Modifier only controller, constructor, pretty straightforward. Same init, same thing. Mint NFT. Called safe mint. And it returns the token ID even. Oh, so here's a little fun piece of trivia. If I remember playing around with this once. I'm pretty sure it's still the case. That thing that you have highlighted right there. So you saw above that next ID starts at 1, right? So when SafeMint gets called on line 51 for the first time, what token ID will the token have? Will that NFT have?
That'll be 1, right?
It'll still be 1.
Yeah.
An increment after the mint. So that's like a cool little hack, but if you don't know that, that's going to be a really confusing line of code. The usage here of token ID equals next ID plus plus is very strange.
Yeah, I don't see that very often in Solidity. I mean, I have seen this before in other languages than JS or whatever.
Yeah. Now, token ID is declared as the return value in 9. Like the function returns token ID. It's just like that's a really funky way of setting it. That also means that token ID is getting set to 1 before next ID increments. For whatever reason, the incrementing there is the last thing to happen. You know, like the value gets passed into SafeMint, it gets set as token ID, and then it increments up to 2. Which is fascinating.
I think it's just a stylistic choice where, I mean, you could have started the ID at 0, and then, I mean, this is probably how I would code it. Just that's how I code. I don't really think too much about it, but I would have put this on a previous line.
Yeah.
And I increased it there, and then set the token ID for this one after that, and then minted.
Yeah, it'd be interesting to see if there's a minute gas difference here, because if you think about it, like when you increment, it needs to read the value, it needs to write the value, and then you'll read it again when you do the mint. And it'll be reading out of storage even. So that'll be an S read. So it could be that there would actually be, I'd guess, like 200 gas of saving there. Though, to be clear, 200 gas is still way under the 1 cent mark. But at the same time, I've leaned towards doing it the way you're talking also, and just for readability reasons.
Yeah, exactly. All right. Yeah. And then that's pretty much the end of the contract. We had that.
What's going on? That before token transfer, something's going on there.
Yeah. So so it calls that controller that we have to look at now. Update operator for the token ID to address 0. Interesting.
We don't know what that update operator is. We'll have to see what that is.
Yeah.
But that's something to kind of keep in mind, that hooks in anytime a token transfers. Wacky.
Yeah, and it's on the before hook. Interesting. Okay, I guess it's time we look at that controller.
Yeah.
Here we are. The controller.sol. Squeeth.
So they're pulling in 721. They're pulling in Uniswap's non-position manager. Fascinating. So what non-fungible position manager is in Uniswap v3 as opposed to Uniswap v2 and its gazillion forks. Actually, you know what? I'll Uniswap v2. And Uniswap v2, as pretty much anybody who's used the ecosystem at all knows, when you provide liquidity into a pool, you receive ERC20 tokens back, liquidity provider tokens. In Uniswap v3, instead of using ERC20 tokens to represent your position in the liquidity pool, there's actually ERC721 NFTs. You can sell them on OpenSea. They even have cool graphics. And that is the non-fungible position manager. It basically gives all of the details to the NFT and like allows you to what's it called? Oh my gosh, let's fail there. Manage. There we go. Your position in the NFT. So yeah, that's that one. Just in case you're ever looking for it, I will point out this gets me a lot of the time when I'm looking for it in Uniswap. It's not in the core. This is in Uniswap splits their contracts into V3 core and V3 periphery. This is in V3 periphery. Okay, cool. We bring in Weeth 9. which is better than Weeth 10 or Weeth 11. But yeah. By the way, did you know that the numbering in Weeth is supposed to go down, not up?
Really? No, I didn't know that. That's
Yeah, it's
weird.
supposed to go down, not up.
Why?
That's been its own weird thing. I can't remember who put out a Weeth 10. Someone put out a Weeth 10, and then David Mihal put out Weeth 11 in Yelp, which is Fuel Labs' kind of extension on Yule that lets you write contracts in Yule. But in any event, yeah, that's just weird trivia over there. They import the interface for PowerPerp. They pull in the interface for short PowerPerp. They have their Oracle, and this itself, it looks like, will receive NFTs because they also bring in IERC 721 receiver, which is the code that a contract needs to have in it for it to be able to receive a 721 NFT. Otherwise, safe transfer will revert. They've got Ownable, they've got Reentrancy Guard, Safe Math from Open Zeppelin because we're still before 0.8, Address, ABDK Math. And then they have a few of their own libraries. They have a library of protocols. They have one for casting a UINT 256. I'm assuming that is either for converting a different number type into 256 or from 256 to it. I kind of would have thought that's what ABDK Math is doing, though. But maybe that's fixed point. I missed the math then as fixed point. And Power 2 Base, which I'm guessing is some kind of exponent library. So it looks like they're going to have custom errors here for pod shutdown. Oh, I'm assuming they're going to have like one error and then a code that goes in it, and this is like kind of the menu of codes.
That's
Call table when it's not food, right? I mean, but yeah, menu.
Where do we see? Where would we go to look for the errors?
I don't know.
I
don't know. It's so it's not a custom error, but I kind of expect some kind of.
There we go.
Yeah, like right there. There you go. Yeah. C21. So a fun piece of trivia that I think usually should know when they're kind of moving out of the junior area into the intermediate area of Solidity is that reverts have a very fascinating feature that they get a lot. Let's see if I remember this. I'm trying to remember if this is a gas problem or a contract problem. I seem to remember it's a size problem, that the amount of size that a revert message like costs you. Okay, let me try and say that over again. I don't know what is with me today. Contracts from the spurious Dragon hard fork on are supposed to be roughly 24 kilobytes of size or smaller. Otherwise, they can't be deployed onto the network. So as a result, sometimes Solidity devs find themselves kind of scrambling to make sure that their contracts aren't too big. And something that's good to know is that require messages have this funny property that they're a lot smaller if they're under 32 characters. So it is actually kind of important to keep your messages small. This is kind of an interesting thing with the Open Zeppelin contracts. The Open Zeppelin contracts do not do this. I'm assuming to make things more readable. They usually will say what contract it is and have a colon and then describe the error actually pretty clearly. A lot of times they will go over 32 characters for it. But the advantage of using a system like this is that you're keeping all of your error messages down to 3 tops, at least specifically with the system. So that's something to bear in mind.
Yeah, I mean, the way I have done it recently on errors is more the Open Zeppelin way, where you sort of have some sort of identifier of the contract that it's coming from, that the error is coming from, and then colon, and then the error string. But I kind of always aim to keep that full string under 32 characters. And then, yeah, sometimes you kind of have to sacrifice error readability to achieve that.
True, say no. Yeah, great short error messages.
All right. All right, should we get in here?
So this is full ownable from Open Zeppelin. Has a reentrancy guard on it. is a NFT receiver using all those libraries. All right, what do we have here? Minimum collateral. Oh, and this is interesting. There's a limit on the pause time. They can only pause it for the first half a year.
Yeah,
After it gets deployed.
that's fair, I think. Like, if it hasn't been hacked in the first half a year.
I think that's actually, yeah, a nice feature, even. I'm like, I like that. I do like that.
Yeah.
Funding period is 420 hours long. I'm assuming that's just for the meme. Fee, not sure what that is yet, but also it is a uint24, which is interesting. Then we have a uint32 for the Oracle. Is a time-weighted a way of creating a time-weighted average. That's the TWNA. And this is, I guess, the period of time that it's time-weighting by. Okay, so there's the lower mark. Do you know what this mark business is and the bounty business is? So,
not really, but I guess this is I'm thinking it's similar to sort of a Uni v3 setup where you have you have your price range. So you probably, in this case, it's like an Ethereum price range, an ETH price range. And you have the sort of the upper and the lower of that price range.
mm-hmm.
Which is in here, it's just sort of a percentage scaling of the index. I'm totally guessing all of this, but yeah. And then, yeah, maybe it has to rebalance or sort of close the position if it falls below or above that range.
Mm-hmm. They did 140 E16 instead of 14 E17, but that's like a really pedantic snipe. Yeah. All right. And then they also seem to need that 10%, that 2%. Explain them on the this probably should be a bit self-evident, but since there are no decimals in Solidity, basically what Ether is, or what Ether looks like to the compiler, 18.0 to 1. There's no decimal point anywhere. And you kind of just have to imagine it there. So 8E17, if you think about it, that means you have an 8 with 17 zeros after it, which means that if you're imagining that there's a point in between like 18 and 17, so then that's why you have that 0.8 there. And then 140 also would be 1.40, and 1E17 would be 0.1, 0.02. They have a constant for 1. I do that in tests, actually. I usually make a constant for just constants.1 whenever I'm testing. It's like 0. Cool. Then we have immutable WEF. I guess they assume that's not going to move anytime soon. Quote currency pool, which, oh wait, no, the @dev there is for the next line, which is where the power perp WEF pool is. Has a Uniswap position manager, but only one. Maybe I'm a bit wrong on the Uniswap structure, and there's one position manager that manages all of the NFTs.
Yeah, I think so. I think that's what it.
I thought we had an NFT. It was like an individual thing. All right. Oh, but maybe it's a factory. Maybe when they deposit, it probably calls a factory and mints them a new NFT. No, but you could just do that.
Wouldn't this be like a library? I wonder. Yeah, Uniswap position manager.
I'll try and pull it up.
I saw. Here it is. Oh, so yeah, it is just a contract.
But itself is the ERC 721 contract. Oh, right. Okay, I'm like, okay, I feel like I'm having a bit of a brain freeze here. So this is going to be the right. I don't know why I was thinking if you've only got one pool. Truth is, you could probably even get it down to one contract. I wonder how. You shouldn't need a new NFT contract for each pool, as long as each kind of knows what pool it's going to. Yeah, I'm kind of rambling. Yeah, okay. For some reason, when I first looked at it, it was hard for me to understand that could be one address, and you wouldn't need more than one position manager. But the more I think about it, the more it does make sense. Yeah, the more they need to be one contract. Cool. So then there's the short power perp, the long power perp, the Oracle, and the fee recipient. I'm assuming there's some kind of system fee that Opyn gets, and I'm assuming that. Cool. Immutable deploy timestamp. We're going to need that, of course, for pause and maybe for some other things in terms of like setting periods and whatnot. And I kind of lost track.
Deploy.
Yeah, good.
Yeah, there we go.
Cool. All right. Oh, even more. Man, that was big. Deploy timestamp index for settlement. The settlement price for each W power perp for settlement. Do you know what that means?
Settlement price for each W power perp for settlement. Okay, so I don't know why it's only like one number though.
Maybe it changes.
Well, I guess this is the index. This is the sort of the scaling factor for like, sort of any rebasing token. Except it doesn't rebase.
Underlying index.
It basically it keeps track of like how much each one token. It's like a C token in Compound. So you have like ETH that you'd put into Compound, and you'd get back C ETH, and then your 1 C ETH will be redeemable for like more than that amount deposited in the future if you've earned interest on it or earned some yield. So I think that's what this is. It sort of works out how much ETH you could redeem your power perp token for, and this should be able to go up or down and make like a profit or a loss, I guess.
Okay, cool. I see here they also limit the amount of times they can pause, and they also record the last time that there was a pause. Cool. All right, there's a normalization factor and a last funding update timestamp. Okay. Bool is Squeeth token 0. I'm assuming because it's Uniswap style, we need to know if Squeeth is token 0 or token 1, but I'm not sure. Bool is shut down and Bool public is system paused. Fine. Mapping uint 256 to vaultlib.vault. Public vaults. Be interesting to understand the vault system more, but I think we should probably focus here. Got a bunch of events. Open vault, deposit collateral, deposit uni position token, withdraw collateral, withdraw uni position token, mint short, burn short, reduce debt, update operator, fee rate updated, fee recipient updated, shut down, or paused and unpaused. Okay, pause, they want to show you how many they have left. And then by unpaused, who did it? Shut down has index for settlement as its argument, which is interesting. Redeem long and redeem short. Okay, fine. So then we have not paused, probably going to be, along with a modifier is paused. Oh, as in there's certain functions you can only call if the system is paused. Modifier for not shut down, and then another one for is down. Fine, constructor. So we need the Oracle address. We need the NFT short address, the ERC20 long address, Squeeth, the quote currency. So I kind of guess what quote currency is if we're kind of like measuring in DAI or USD. So it would be the address of DAI. But yeah, even though technically, everything's Squeeth.
I think it might be a pool as. Oh, sorry. There's the pool. Yeah. So this would probably be like DAI, and then this would be the ETH DAI pool on Uniswap.
Mm-hmm.
I think. Yeah.
Mm-hmm. For Squeeth, yeah, for Squeeth divided by quote currency. I mean, just because I'm assuming having ETH by itself, like if the only currency you're aware of is ETH, so then one Ether will always be one Ether.
Yeah.
Going up or down. Unless you're a true maximalist. So then you have your W power your W power per pool 3 times fast, which is Uniswap V3 pool for W power perp does. And Squeeth, and then also the fee tier. Interesting. So there's really like a lot of moving parts here, which is interesting. You've got your short, long for DAI, you've got your Uniswap pools for Squeeth DAI, you've got also the Squeeth Power Perp pool. Well, yeah, there's like a lot of stuff going on. Fine. So then, yeah, it sets all those addresses over here. Is Squeeth token 0 is if Squeeth is less than power perp. As in, the way that Uniswap is going to set token 1 is going to be actually which address is bigger than the other. So Squeeth will be token 0 if it's less than power perp. Okay. Normalization factor is 2018. Sense. I'm wondering why they need to set the normalization factor even. Not sure. And like you pointed out before, deploy timestamp is block.timestamp. And then
oh wait.
Cast letter.
So I think this starts as 1 with that 1E18 is 1 in their system. And then I guess from there it's going to increase or maybe even decrease at times.
I kind of assumed that was just like their way of knowing that they're dealing with an 18 decimal currency. But if it's actually for calculating stuff, yeah, that makes a lot more sense.
So yeah, I mean, I noticed they had that 1. I assume this is for the scaling.
Right. And yeah,
then,
good point.
And the normalization factor, where's that? That's not a constant, so that I assume is going to change. And it's so that something's going to happen here.
Good point.
All right, external functions. Right. Well, they just.
So yeah, that's a view. Just gets that. Views, I'd say we could probably breeze through pretty quickly here.
All right.
Next view function, fascinating. Get the index price of the power perp scaled down. It's scaled down by the index scale space library. This is the index price used when calculating funding and for collateralization. Period in which you want to calculate the time weighted average with, and the price denominated by 18. So, all right. So what is this going to mean? When we talk about the index of the power perp, and I guess maybe I'm not understanding what an index is. Like if I bought in with 1 ETH in the beginning, and now ETH has 3x'd. So I have, however, I guess my first question is how much Squeeth I got in the first place. Like, do I get 1 Squeeth if I put in 1 ETH?
I think it would be like, how you get a kind of an
LP token.
Yeah, LP token or a vault token where it's you don't know exactly the amount you're going to get out, but it's representative of your share. I think it's that. So like as you're entering the Squeeth pool, it'll be based on the price of ETH at the time, and sort of like.
And then share the pool based on that.
Yeah, so you would get your share at that point of time, and then if other people were in the pool before you and ETH had already increased, and they would have like an exponential increase in their amount. So when you come in, you should have a lower sort of share of the pool if that person and you were putting in the same amount of dollars.
Mm-hmm. Mhm. But the amount of token that I'm holding doesn't necessarily go up, even if its value does also, which is, I'm assuming, where the index comes into play. Like one Squeeth equals however many ETH. I'm assuming
Yes.
is the index. All right, cool.
I think that's what the index is doing. Yeah.
Okay. And then what it's returning is it's returning the value in DAI also, which is interesting. It's not saying how much ETH it's worth. It's saying how much DAI it's worth, or whatever token they're using. They say
Yeah, I get
USD, so however they're doing USD over there.
that's more intuitive. I think because it'd be quite weird if you're like if you're getting your thing priced in ETH, so you enter it when ETH is at like $2,000, and then ETH triples to like say 6,000. Now, like I wonder what your price in ETH would be. Like,
Right.
yeah,
What's the payout in though? The payout is in ETH, no? So I mean, your ETH value is going up and down.
it's a good question. I wonder if it is cash settled or just like pays you out in ETH, because it could pay out in either, I guess, but it'd have to do an extra swap through
Yeah, we
Uniswap.
need the DAI from somewhere. And if all the funding is coming in ETH, it makes sense that all the payments are in ETH too.
Yeah.
Yeah. Oh, all right. Then we have the unscaled. That's the mark that would be used for future funding after a new normalization. All right, something I also don't fully get, but I get that this is kind of a moving target now. As in, like, the index itself, of course, is moving around. So there's one where it's scaled, one where it's unscaled. It's the same thing. The only difference is the 18 zeros. Or am I completely off?
Scaled by 18. I mean, they both have that.
The top one doesn't have 18 zeros, no? Oh, yeah. Not bad. I thought we said scaled down. That meant that it took it out.
Here it says maybe they just copy pasted this wrong, because here it says, yeah, scaled, and this one is just scaled down. Should we just check out these functions real quick? Oh, gosh. Oh, it's from the Power 2 base.
Yeah, let's skip it for now.
Right.
I won't get bogged down in it. We don't got that much time left.
Yeah. Okay, we're still
all right. Denormalized mark. Get the expected mark of power perp after funding has been applied. Period, time for TWAP in seconds. Okay, fine. So this is getting the expected price after funding to buy more of the power perp, I think, unless I'm wrong. And again, it's going to have to use that power to base library. I mean, in my mind, kind of looking at this, I have this as like, okay, this is the mathy stuff, which is probably a bad way to look at this if I actually want to understand it. But
yeah. Maybe we should
normalize
freeze through it, and then
that might be a good call. Yeah, that might be a good call. Get normalized mark for funding. Okay, cool.
Cool is hold safe.
Whoa, what's that mean? Oh, if there's enough collateral. Okay.
I see.
I usually think of safe in different terms than that, but I get what they mean there.
Okay, so here you mint.
Here we go.
I guess this is where you're entering your long position on Squeeth.
Oh, so there is a rebasing thing here. Deposit collateral and mint W power perp, non-rebasing, for specified power perp amount. Power perp amount is the amount of so there's W power perp and then there's power perp. So the wrapping, okay, this is something that we were actually just talking about with Ohm yesterday. Yeah. It looks like you've got an underlying power perp token is rebasing, but then that's wrapped into W power perp in order so that you have a stable wrapper, like kind of a stable index, which isn't bouncing all over the place. So you specify how much of the rebasing token you want, and then you mint an amount there. But the amount that you're returned is the amount of wrapped power perp that you have. Like the underlying number that's moving all around, but your W power perp should stay stable.
Yeah, exactly. So it's essentially a share of a vault, if you're thinking of that vault as the rebasing token, where the total supply could go up or down. And it's your share of that total supply.
Yeah.
So this one doesn't change. Yeah.
Interesting. I kind of feel like Ohm and now Squeeth, they're kind of when rebasing tokens came out, it's kind of like novel and interesting. Ampleforth tried making a stable coin based off of tried making whatever on Earth based was off of it. But that really there's a lot more than just key poorly working algorithmic stable coins.
Yeah.
Yeah, funky. Okay, cool. I wonder why you need the uni token ID. Uniswap v3 position token ID. Maybe that's another. Oh wait, maybe. I'm guessing that you can also. So you can also put in your uni v3 position. I mean, it says right there in the NAT spec. So I'm guessing you could actually do a power perp amount of 0. But you could put in your Uniswap v3 LP, or alternatively, you could put in a 0 maybe the token. I wonder. And then power perp amount is deposit. I'm not sure. Maybe I'll leave that as a bit of an open question there.
I think this is the amount of power perp tokens you're minting. We should look at this. Maybe should we just go to that function?
Yep. Yeah, go for it. Go for it, man. That makes sense.
We don't have all the time in the world, and this is a important function, I think. Yeah. So mint amount, I think that's where that amount from the external function was coming in. Or was that deposit? No, I think you. What?
Let's go back up. The min amount is the amount to min. I think you'll see that in the NAT spec right there.
Deposit is the message of value, so the ETH you're sending in. Okay, cool. Let's just read this real quick.
Yeah, mint amount is the amount to mint. Deposit amount is the amount of ETH of collateral. Is W amount if the input amount is a W power perp amount as opposed to rebasing. Acted on, or for a new vault, the newly created vault ID, and the minted W power perp amount. Okay.
So, okay, I see.
You get the vaults yet?
Sorry?
Do you get what these vaults are yet? I'm assuming they're kind of holding the funding.
Yeah, I don't know how they manage the sort of the multiple vaults. I assume like some will get liquidated at different times.
That's why they need to be kept separate. Yeah. It's like an internal accounting so that you can see if something. Isn't this supposed to be a no liquidation system?
Yes, I believe so, but
there probably still is something with the funding, though, like the way the funding is distributed or something like that.
Yeah, up here. So shit.
Somewhere there.
Where was it?
The errors, maybe.
Here, liquidation bounty.
Oh yeah.
10%. Which is interesting.
Yeah, good point.
Okay. Anyway, so we basically need to calculate how much W power per token to give them based on their ETH that they've deposited. And that's the normalization factor. Yeah. So yeah. So working that out based on this normalization factor. So essentially you're saying mint amount, and this, I don't know if this is less than 1 or greater than 1. I guess it could be either. And it
I was about to guess.
Scale your mint amount up or down based on where that token's worth is based on you. Yeah. Interesting. Applied funding.
If the amount deposit with fee, get fee, meant with power perp. If deposit amount is greater than 0, add ETH collateral. So yeah, basically, it does look like it's a universal function. It looks like it can either be taking W power perp, WETH, or an LP token. I'm actually really interested. This is the first time I remember seeing a repo that's interested in accepting a Uni V3 position. If you wouldn't mind diving into the deposit LP, it's a little bit down from what's on the screen for me right now. Deposit Uni.
Where? Sorry, you're cutting out.
The deposit Uni position token. Yeah, that one.
Should I go
Would
find
you mind diving down to that? Yeah.
There we go.
So we have the account, the vault that it's supposed to go to, account to transfer the Uni V3 position from. So that's kind of like the message, or maybe it was an approved position, someone else, fine. Vault ID of the vault, and the Uniswap position token ID. Okay, so get tokens for Uniswap NFT. Okay, so for the end of the construct called positions, which has a view function that allows you to return it from Uni V3. So let's just see what we need here. We need the token 0, the token 1, the fee, and the liquidity. So the pool and the liquidity, I wonder if that liquidity number is actually kind of like the number of V2 tokens you would have gotten. You know what I mean? Like your shares in the pool.
Yeah.
So require the liquidity of 0. Accept NFTs only from the W power per pool. And for that, you require fee equals fee T.
Oh, right. So when they set it up, because on Uni you could create different pools with different fee settings, right? So they've probably like seeded some pool with liquidity, and they're wanting it to be that like other people can't create new pools with different fee settings and then use this. You deposit those LP tokens. Sorry, you're cutting out there.
What? Oh, sorry. Why not just hard code an address then? Not sure about that.
Yeah, I don't know.
Yeah. Either way, though, the tokens, and then they added as collateral. Fine, emit, deposit, Uni position token. So that's how it deposits. I'm hoping I did the last to figure out how to mint for this. You know what I mean? Like how much they mint back. That was kind of what I was wondering for. Time, as classically, we managed to not make it through the entire controller contract. It's definitely been like it's interesting to see how they're pulling this. It's been really interesting to look at the Uni V3 stuff for me, but I do think we're probably going to have to leave it here. I think this is traditionally where we would make a promise to get back, but Andre Kanye released the article yesterday, so I don't know if I want to make any promises about that yet.
Yeah, I'm super hyped to dig into Andre's V33 system that he's about to release on Phantom. But this is also so interesting, this Squeeth contract that we've been going through.
Yeah, a lot of cool stuff here.
Yeah. All right.
All right then. So, been a pleasure, everyone. So